Hello, students. Let me begin with a thought. Have you ever noticed that while a calculator can solve many problems, there are still some tasks it simply cannot handle? The same goes for dimensional analysis. It's a powerful method to check or derive equations, but it does have its boundaries. In this lesson, we'll uncover the important limitations of dimensional analysis. Understanding these limitations ensures we don't misuse this method when solving real physics problems. Let's start with the first limitation. Dimensional analysis cannot give us the value of dimensionless constants. For example, consider the time period of a simple pendulum, t equals to pi multiplied by the square root of L divided by g. Now, dimensional analysis can only tell us that t is proportional to the square root of L over g. But it cannot predict the exact constant to pi. This shows us that while the method checks dimensional correctness, it cannot capture numerical constants that arise from geometry or deeper theory. Here comes the second limitation. If a physical quantity depends on more than 3 factors, dimensional analysis falls short. Why? Because we only have 3 fundamental dimensions to work with: mass, length, and time. This means we can only form 3 equations by comparing their powers. If there are 4 or 5 variables involved, the system cannot be solved completely. For example, complex relations in aerodynamics or fluid mechanics often involve many variables, beyond the reach of dimensional analysis. Now to the third limitation. Dimensional analysis cannot handle equations that contain trigonometric functions, exponentials, or logarithms. For instance, consider the displacement in simple harmonic motion. Y equals a sine of omega t plus pi. Here sine is a mathematical function, not a physical quantity with dimensions. Similarly, exponential terms like e to the power minus x cannot be checked using dimensions. This makes dimensional analysis ineffective when such functions are present in an equation. Finally, the fourth limitation. Some different physical quantities share the same dimensional formula. Take the case of work and torque. Both have the dimensional formula ml squared t power minus 2. Yet, they are conceptually very different. Work is scalar, while torque is a vector with direction. Dimensional analysis cannot distinguish between them. This creates ambiguity when we rely only on dimensions to identify a quantity. So, let's quickly revise the key points. Dimensional analysis cannot calculate dimensionless constants like 2 pi. It becomes unreliable when more than 3 factors are involved. It cannot analyze equations with trigonometric, exponential, or logarithmic terms. And it cannot differentiate between different physical quantities that happen to share the same dimensions, such as work and torque. Despite these limitations, dimensional analysis is still a valuable tool to check correctness and derive approximate relations in physics. But we must always remember its boundaries. I hope this session has helped you see where dimensional analysis works beautifully and where it does not. Until next time, keep questioning and exploring the beauty of physics.